Hello again, I'm Dr. Taylor, the Undergraduate Exercise Science Program Director and Associate Teaching Professor at the University of Kansas. I'm here in the KU Edwards campus Exercise and Human Performance Lab with Matt Hermes. Actually, I should say Dr. Matt Hermes, since he just completed his dissertation defense and is now a freshly minted Ph.D. So congratulations on that accomplishment, Dr. Hermes. So I was a member of Dr. Hermes' dissertation committee, and I invited him on the show today to talk about what he's been investigating. So welcome, Dr. Hermes.
Thank you. Thank you.
So can you briefly discuss your dissertation research, describe the purpose, hypothesis, and the methods used?
Absolutely. So what we wanted to look at with this project was we wanted to compare different velocities and see how that influenced exercise performance. So what we did specifically is we had 4 different velocity conditions that we used with the bench press exercise. We had 2 that were intentionally slow. That was 1 second on the way up and 3 seconds on the way up, and 2 that were a little faster. So we had a self-selected, so they got to pick how fast they lifted the weight up, and a maximal velocity condition, so they moved it as fast as possible. And what we wanted to do is we wanted to compare the kinetic, kinematic, and EMG performance between all those different velocities. So with kinetics and kinematics, I'm thinking force, power, things like that. And we were looking at muscle activity as well. So what we hypothesized was that the slow conditions were going to have lower performance than the faster conditions. But even further, we also hypothesized that there was going to be a divide between the self-selected and maximal velocity conditions, that a self-selected speed wasn't going to produce as much or as high of a performance as the maximal velocity.
Okay, and you mentioned EMG. Can you tell everybody, what an EMG is and what that stands for?
So EMG refers to electromyography. So it's talking about the electrical activity of the muscle. So there is research that has compared the electrical activity and compared it to things like motor unit recruitment, things like that. So higher EMG activity may represent more motor unit recruitment, muscle fiber recruitment, things like that. So if we're talking, say, strength and power performance, having a higher EMG or a higher motor unit recruitment is going to be beneficial because essentially we're activating those bigger, stronger muscle fibers.
Right. Produce more force, right? We'll talk more about your results and conclusions in a bit. So on to question number 2. Okay, so we've got some variables up on the board. Let's talk about how these variables such as force, velocity, power, how they're all related to your research project.
Yeah, absolutely. So looking at these are variables that are often tracked or manipulated in resistance training programs to try to elicit different adaptations, right? Getting stronger, getting more powerful, and things like that. But it's very hard to think about these variables in isolation. We can see that they're all highly related, and if we change one, there's going to be an influence on the other variables. So that's an important factor to consider when you're changing somebody's velocity, or if you want to produce more or less force for some reason, to understand how that influences the other variables. I like to start with velocity on the top here because it's one of the easier ones to manipulate, right? You or I could go into a fitness center anywhere and intentionally go faster or slower with the exercise.
And it was really the focus of your project.
Absolutely.
How changing velocity influences things.
So if we're talking intentionally slow velocity, right, we can assume that we're going to move the same distance with the exercise, whether I go fast or slow.
Right.
We're about the same. So we're keeping the distance the same, but we're just taking an increased amount of time to complete the lift, right? So what does that do? Well, that decreases our velocity.
Yep.
And we can see if we go down to the next variable here, we have force, and we're going back to physics class, right? Remember our Newtonian laws. Force is mass times acceleration, but we can take that out further because acceleration is the change in velocity over the change in time. So we've already talked about how intentionally slow training decreases velocity because we're increasing the amount of time that we're taking. Even if we keep the weight the same, the mass on the bar, that's going to lead to a reduced force.
Right.
Now, power is the rate at which we do work, and we can take work out a little bit further. If work is force times distance, so we have force times distance over time, or force times velocity. And we already talked about how intentionally slow reduces velocity and reduces force, so we might have a substantial reduction in power output.
Right. Okay, so since your work is so focused on these relationships between the different variables we talked about, force, velocity, power, can you kind of run us through this common curve, the force velocity curve that coaches, athletes, personal trainers, many in the industry should be familiar with, and then also talk about kind of how this curve is misinterpreted.
Yeah. So the force velocity curve, what it shows is it's essentially showing the inverse relationship between force and velocity, right? So when we see if we have high levels of force, we're on the lower end of velocity. If we're on the high end of velocity, we tend to be on the lower end of force, right? So I like to think about the high force end as heavy loads. Like if we're doing, say, like a 1 RM squat or a 1 RM deadlift, we tend to be on the higher force end. Whereas the higher velocity end is things that maybe don't have as much external load, but you're moving very fast. So a jump squat or a sprint or something like that. The common misinterpretations of this curve are often what is interpreted on the high force end. Coaches will often look at this and say, well, when I move slowly, I produce a ton of force, right? And it's not the slow movement that causes high force. If we're on the high force end, we're generally working with 1 RM or maybe 95% 1 RM loads, and that's what causes the slower movement. You're still trying to move as fast as you can, and it's important to understand that regardless of where we are on this curve, we're trying to move as fast as possible.
Right. Intentionality is key, right?
If we move slowly on purpose, as we saw with the equations before, we're going to have reduced force, we're going to have reduced power. So even if we're, at this point or this point on the curve, we're moving as fast as possible, even if it takes a little bit longer because we have heavier weight on the bar. If we move slower on purpose, we'd have to draw a new curve because we'd be somewhere down here and we would have suboptimal power, suboptimal force, and intentionally slow velocity.
It makes me think back to my strength coach when I was, playing football in junior college. He would walk by and just, pretty much yell at everybody, bar speed. Like no matter how heavy the load was, if it was a heavy load, yeah, it's a heavier load. You're by default going to lift it more slowly because it's heavy. But, he was trying to get that in your mindset to explode and push that bar off your chest or come off the ground as quickly as possible, no matter how heavy or light the load was. And I think that translates to some performance on the field, obviously.
Oh, absolutely. And, like you said, even if you got a heavy load on the bar, trying to move it as fast as possible is important. I would challenge anybody to take their 1 RM back squat and try to do it slowly.
Right. So basically you're saying this whole thing about you can take a really light load and just really slowly off the chest, and that's going to help improve your power, your strength, your performance on the field. It doesn't really translate based on some of your findings in this research. All right, so let's get into the results of your study now. How does resistance training velocity, the repetition speed, bar speed, affect performance characteristics and muscle activity as measured by EMG? We talked about EMG earlier.
Yeah, so essentially what we found was that there were significant differences in performance when we influenced velocity, when we changed velocity. So we had those intentionally slow conditions, and what we found was that when we intentionally moved the bar slowly, we had reduced force, reduced power, and generally lower EMG activity, right? So there wasn't as much electrical activity in the muscle, and they weren't performing as well on the kinetic and kinematic variables.
And again, the muscles you looked at, pectoralis major, anterior deltoid, and tricep,
correct? Yeah,
okay.
So the prime movers in the bench press.
Right.
So essentially what we found is that bar speed matters if we're looking at kinetic performance, kinematic performance, and EMG activity. If we want to activate those muscles and we want to move forcefully and powerful with a lot of power, we want to increase the bar velocity.
Right. And for most sports, you would argue, I'm sure, and I do, that power, the ability to display force rapidly and quickly is more important than strength, even though strength is a component of power, which is force production.
Right.
So
yeah, absolutely. Well, if you think about it, a lot of sporting movements happen very rapidly.
Right.
So that increase in the rate of force development is very important. So if we want to perform that way, it's very important to train that way.
And really what your research does is validate what strength coaches have known for years. I've talked to Matt Sanders, a former strength coach. He used to work with the Reds, and I worked with in Wichita, his private facility. We talked to Dr. Fry about this, but your research basically validates what strength coaches have known for years and been implementing in practice, that like my coach said, bar speed. And I used to preach that with athletes and people that I train, try to intentionally move that load as fast as you can. Even if it's heavy and it's going to go slow, in the mind, you've got to focus on explosiveness. So, all right. So what are the conclusions, the practical applications of your research? How can your findings benefit coaches, trainers, therapists, athletes, and just members of the general population that are interested in strength training?
Absolutely. Well, based on our conclusions and our findings that performance was influenced by velocity, if we want to keep force high and we want high levels of power, it's important to move the bar faster. And now we only looked at one repetition. And of course, performance was different in that one repetition. But if we expand this out to a set, an entire workout, or a multi-week block of training, if we're consistently producing less force and less power, and we're not having as much EMG activity and muscle activation, that's going to influence adaptations over time. Right. So this is going to have a big influence on strength adaptations over time. So the intention behind how fast you move the bar, regardless of the load on it, is important for strength and power adaptations over time.
Right. And really, force production is important to anybody, not just athletes. We always think of it in terms of sports, but think about an older adult. Yep. You've got to produce force to stand up off of a toilet or off of the couch, right? To bend over and pick up a load of groceries. So it's important for, really anybody and everybody.
Yeah. I mean, if we're talking older individuals too, that's where you get in. They lose those type 2 motor units a lot sooner than they lose the other muscle fibers and things like that. So training in a way that's going to activate and stimulate those muscle fibers is very important.
Well, thanks for coming in, Dr. Hermes. How can people get a hold of you if they have any questions about your research?
Well, I am on Facebook and Instagram if you want to reach out on social media, as well as, my KU email address is m602h699@ku.edu. But I know pretty soon I'll be getting a Murray State University email address.
Congrats on that. So, if you have any questions for me about the KU Exercise Science program, you can contact me at jtaylor@ku.edu, or phone number is 913-897-8516. Thanks for watching.